CPM Math 3, Problem 1-99. We're being asked to use negative exponents, and you need to be really fluent with negative exponents this year. So for problem A, we have 5 to the negative second power, and we need to recognize that that means divide by 5 2 times. It does not mean negative 5 times negative 5. One more time. Does not mean negative 5 times negative 5. It means divide by 5 2 times. So how do you actually show that? Well, what we talked about in class is that you take that and you basically shove it into the denominator. So it becomes 1 over 5 to the second power, positive 2. It changes it into a positive. So then we end up with 1, whoops, excuse that little glitch there, 1 over 25. Okay, here we have x times y to the negative second. Now, x has an invisible positive 1 exponent right now, so he's fine. He does not need to be moved. It is not dividing by x because x is in the numerator. It is being divided by y twice because y has a negative exponent. So all we have to do is take our fraction. X to the first stays in the numerator, which it is right here because this is all over 1 technically. And y to the negative second gets bumped down into the denominator so that we can make its exponent into a positive. There we go, done. Over here, completely different than what we experienced with problem B, because this negative 2 applies to everything in the parentheses. So that becomes x to the negative second and y to the negative second. Okay, so therefore, if we create our fraction bar, this x to the negative second has to bump down in order for that to turn positive. The y to the negative second also has to bump down in order for that exponent to turn into a positive. And then all that's left in the numerator is a 1. All right, so D, super interesting. I'm going to create my fraction bar. A to the third stays put. B to the fourth stays put. He's positive. He doesn't go anywhere. A to the negative fourth, ooh, he's going to bump down and become A to the fourth. And B to the sixth, he also stays put. Now, what I'm noticing here is that I have I have A's here and I have B's here, so we do need to handle that. So A to the third over A to the fourth. If I have 3 A's up here and cancel 3 A's down here, I'll be left with a single A in the denominator. And B to the fourth, I have 4 B's multiplied and then another 6 B's multiplied. That's going to give me B to the 10th. So I end up with B to the 10th over A.